So yesterday we were learning about this problem, that is regression equations, and we only solved a first part of the problem where the regression equation we were learning was y on x. So you have this expression, and when you derive from that expression you get two other equations. Now keeping these equations, we are supposed to calculate few major values from the problem, that is sigma x, sigma y, sigma xy, and then sigma x square. So these are the important things that has to be found from the problem, and then we are supposed to know the value of n also. Now we went on to this problem, and here we only were able to solve the first part of it. Let's just revise that once again. We have the data of x, we have the data of y, and we are supposed to obtain both the regression equations. Both regression equations is y on x is the first regression equation and x on y is the other regression equation. So to find out these regression equations, first we will only concentrate on y on x regression equation, and if you we have to calculate this value. So we wrote down all these values in the solution with the heading formulation of regression equations. Now once you write down, the first important value is summation x. So add all the part of x or all the numbers in x, so you get summation x. Then is summation y. So add all the values of y, you get summation y. Now going on further, the next important value was xy, that is multiplication of these two columns, that will give us xy here. So xy is equal to 260. So we are supposed to multiply all the numbers here, and once you multiply all the numbers you get this column. And after that you are supposed to add all the numbers here, that will give you the total. So that is summation xy. Next, after calculating three important or major calculations, our next important calculation for equation y on x is x square. So square this column, that is x square, and whatever numbers you get, add them up to get the important information, that is sigma x square. As of now, ignore this column of y square. This is not required for now. When we come to x on y, that time we will consider this. Okay. Going on further, we have to write the basic regression equation of y on x. Now the basic regression equation of y on x is yc is equal to a plus bx. Here we are going to solve the value of a and b. Okay, so for the rest of the values we have to for this x and y values, sorry for that, for the x and y values, you have these two simultaneous equations to be calculated. So first one is summation y is equal to na plus b sigma x. Then the second equation is summation xy is equal to a summation x plus b summation x square. So here in y of x you will have x square. Okay, now let us substitute all the values into the equation. 40 is equal to 5a plus 35b. Okay, and then the next equation is 260 is equal to 35a plus 275b. Now once you have these equations, we are supposed to solve it simultaneously. Now for solving it simultaneously, we should actually make one of the variable as equal. Either a or b, any one of the variable must be equal. Now in this, if you observe, we can make a as a equal variable because you have very less value, or the unit value is less here. So I am multiplying equation 1 into 7. Now why I am multiplying equation 1 into 7? Because if I multiply 5 into 7, 5 sevens are 35. Okay, so then the second equation value here, if you see, is also 35. So I can easily get the value directly. So that's the only reason I multiply the whole of equation 1 with 7 here. Okay, and the second equation I can multiply it with 1 so that it remains as it is. So multiplying first equation with 7, 40 into 7 is 280, 5 into 7 is 35, 35 into 7 is 245. Next, 260 as it is, 35a as it is, 275b as it is. Why it is as it is? Because we have multiplied it by 1. Okay, now next we have to subtract both the equations. Now solving simultaneously means subtracting the equations. Now when you subtract, the signs of the equation will change. You had a plus here, so it will become minus. Again you had a plus sign here, it will become minus. Again plus sign, minus. Now for this equation you have to consider these signs here. So 35a plus 35a and minus 35a will get cancelled. Okay, so that expression is gone, or that variable of a is cancelled, so we are left out with only variable b. So 245 minus 275. Okay, now this will become minus 275. So 245 minus 275 will give you minus 30b, and 280 minus 260 will give you 20. Now going on further, we have to find the value of b. So what we are doing is, we will take out one after the other variable to the other side. Now if you take this equation only, now after this step we can write it as, or we can take this 30 minus 30 onto the other side. So that time what will happen, 20 divided by minus 30 is equal to b. Okay, so that is what we have written here. B is equal to 20 divided by minus 30. So, and what is the total value of B? The total value of B is minus 0.6667. Okay, so this is the first major step in solving simultaneous equation. Any doubts until here? So nobody has doubt, let us continue. Now, once we are done until here, now we will be substituting this value of b into the equation. Now, any one of the equation we can take and substitute the value. So this value of 0.6667, that is minus 0.6667, we will put them into the original equation. So here we are considering the first equation from the original equations here, and in this equation we are going to substitute the value of b to minus 0.6667. Okay, so in after substituting we have to simplify the expression or the equation. So this is, one second. So here the equation is 40 is equal to 5a plus 35b. So 40 is equal to 5a plus 35 into, in the place of b, minus 0.6667. The next step, 40 is equal to 5a 35 into minus 0.6667. So this 35 into minus, it will become minus value again. So plus into minus, your minus value. So 35 into 0.6667 will give you 23.3333. Fine. Now after this, we have to just interchange the positions here. That is 5a will come out and 40 will come in. Okay, so 5a we are taking to the other side because we will get the expression of a, and 40 is a constant which we will take it inside, so that we will be able to add or subtract them. Fine. Now so since this it is like changing complete, it's like also changing the position of minus 23.3333, so it will change from minus to plus. Okay, so now 40 plus 23.3333 will give you 63.3333. Okay, is equal to 5a. Now 5 is multiplication. When I take it to the other side, it will become division. Now a is equal to 12.6667. So we have found out what is the value of b. So this is the slope of the equation, and the value of a, this is the intercept. Okay, this is the intercept of the equation. Okay, so any doubts until here? Did you all understand? Okay. Now, once we know the value of a and b, let us put that into the original equation of y on x. Okay, y on x original equation is yc is equal to a plus bx. Now, if you go back to the question, here they say if, hence predict y if x is 5. Okay, this is important for us. Okay, x is 5, the value of x is given. So y is equal to a is 12.6667, a is equal to 12.6667, and b is equal to minus 0.6667. Okay, so a is equal to 12.6667 minus, this is actually, you will be writing it like this: y is equal to 12.6667 plus minus 0.06, sorry, minus 0.6667 x. So here again plus into minus, you will have minus only left out, so directly they have taken that minus. Okay, so the next step is, in the place of this x we are gonna substitute it by y, sorry, substitute it by 5. So y is equal to 12.6667 minus 0.6667 x. In this place of x we are substituting 5, so there I will put 5. Now multiply 5 into 0.6667, which will give you 3.333, and 12.6667 minus 3.333 will give you 9.3334. So knowing the value of x, we have predicted or we have calculated the value of y. So that is why this complete calculation what we did until now is on the regression line. Okay, is on the regression line of y on x. Okay, is on the regression line of y on x. So this is how we solve y on x regression. Any doubts in y on x? Okay, so we understood how to calculate y on x. Now let us go back to the problem once again, and we will be solving now x on y. Okay, so until now we had y on x. Now we will be solving x on y. Now x on y, the regression equation x on y is represented as xc. Now in y on x you had yc. Okay, xc, here it is xc. Xc is equal to a plus by. So there it was a plus bx. Are you able to understand the comparison? So I'm writing both the equations here. If it was y on x, okay, if y comes first, you will have y here. Okay, if x comes first, you will have x here. Okay, so then here, which means that here again you will have the value of y given, where you will find the value of x. In the equation x on y, the value of y will be given, where you will be able to find the value of x. And rest of them, it's all pretty same. That is, the a is called the intercept or interceptor, and b is called the slope of the line. Now how we had two equations for the first regression line, similarly for x on y also there are two equations. These two equations are very similar except this last one variable. Now for y on x, okay, so for y on x, what was the equation? Wherever you have, see, you have a sigma x y, and then see you have sigma y and then sigma x. Okay, so that will be interchanged. So you will have summation x plus is equal to na plus b summation y. Then xy will remain as it is. Then here you had summation x and you had summation x square, but here you have summation y and summation y square. So this is x on y. Okay, so for y on x, if you see, you had summation y is equal to na plus b summation x. Okay, then summation xy would remain same, which is equal to a summation x plus b summation x square. So this was the expression for y on x. Now wherever you have y, you are supposed to take it as x. So this place of y, if you see here, has been interchanged by x. This place of x is interchanged by y. Okay, and this place of y is interchanged here. This place of x is interchanged by y. X square is interchanged by y square, and xy will remain as it is, because if you multiply x into y or y into x, both means the same. So that is the equation on x on y. Okay, did you understand x on y? Are you able to, will you be able to remember this? Okay, so now let us solve this question, the second part of this question, because they have asked two regression equations. So we first solved y on x. Okay, we first solved y on x. Now let us solve x on y. Okay, now again for x on y, you require mean values, that is summation x, summation y, summation xy, and summation y square. So these are the important terms for x on y. Now what were the important terms for the first part of the question? Same thing, summation x, summation y, summation xy, and summation x square. So here it was x square which was important, here it is y square which is important. So that is why in one table only we will be solving both x square and y square. Now if you see here, same problem, the values will remain same, x summation x, summation y, x square will not, we will not be requiring x square for now. Okay, we will ignore this column. Next, y square is required, so square this column of y where we have y square. Then add them, so you get summation y square. Next, xy. If you multiply x into y, you get xy. So this is the information that we require for the required to solve the equation of x on y. Okay, now let us go and solve the second part of the question, that is from here. Regression equation x on y is xc is equal to a plus by. Now to solve this regression equation, we have to solve them again simultaneously. But to solve simultaneously, we require two equations. So let us form those two equations. So that will be summation x is equal to na plus b sigma y. That is equation number 1. And then you have summation xy. Okay, so summation xy is equal to a summation y plus b summation y square. So this will be your second equation. Now let us put all the numbers. Summation x is 35, n is 5, a as it is, b and summation y is 40. Then next, that this will become your equation number 1. Now equation 2 is summation xy is 260, and then you have a into sigma y is 40, and then y square is 334. Now if you see these two equations, you're supposed to solve them simultaneously. To solve it simultaneously, we have to again make one of the expression equal. So here this is small a and small b. Just correct it as small a and small b. They are not capital A and B. Okay. So to correct or to make one variable same, if you see variable a, again 40 is a multiple of 5, right? So 8 fives are 8 into 5 will give me 40, right? So what I'm going to do is I will multiply this whole equation by 8, so that I will get a 40a here, and I can cancel them together in simultaneous equation. Okay, and for the second equation, since I don't want any changes, I will just multiply that into 1. Okay, so going on further, my new equations will be 280. How did I get 280? 35 into 8. Okay, 35 into 8 will give me 280 is equal to 40a plus 320b. Then again 260 is equal to 40a plus 334b. Now I'm supposed to subtract these two equations if I have to solve them simultaneously. So subtracting means I have to change the signs of this equation, that is the second equation. Okay, so plus will become minus, again plus will become minus, and again plus will become minus. Now if you see the expression, plus 40a and minus 40a will get cancelled. Okay, so the complete expression of A will get cancelled. Going on to the expression B, you have 320 minus 334. So there is a 14 difference, but there is a negative 14 difference because it is 320 and 334. So minus 14B. Then you have 280 minus 260, which is 20 again. Now, what we will be doing is, one second. So like the previous expression how we solved, here also we will be solving, or we will be taking this minus 14 onto the other side. So this will become 20 divided by minus 14 is equal to b. And sorry, here this is minus 14 and not 40. Okay, so 20 divided by minus 14 is equal to b. Now if you divide them by b, then you get 1.428. Okay, this is 1 point. Okay, 1.428. So you 1.428. So here you can round it off and write it as 1.43. That will also work. Now once we get the value of b, let us substitute this value of b in the original equation to get the value of a. Now what is the original equation? The original equation here is 35 is equal to 5a plus 4b. This, okay, we are using this equation and we will substitute the value of b. Now 35 is equal to 5a plus 40 into sorry, 35 is equal to 5a plus 40 into minus 1.43. Now once I multiply this and simplify, I will be getting the value of a as 18.44. Okay, so I know the value of b, which is minus 1.43. I know the value of a, which is 18.44. Now let us apply this into the regression equation, that is x on y regression equation. Now we will take regression equation, that is x is equal to a plus by. So x is equal to a is 18.44. Okay, b is minus 1.43, so they have taken it directly. Okay, so minus 1.43 y will remain as it is. Now going back to the question, if you see here, they are saying predict x if y is equal to 10. Okay, so they have given the value of y, we have to find the value of x. So y is equal to 10, so that is important for us. Now y is equal to 10 will have to be substituted at this place or this step. Now we will be substituting y is equal to 10. Now when you substitute y is equal to 10, this 1.43 will become 14.3, and the value of x at the end after simplification will be 4.14. So this is how we find the value of x and y when the regression is on x on y. Okay, so that is your first question, complete solution with two regression questions, that is y on x and x on y. Both we have solved in one question only. Any doubts in this question? Any part you want me to solve it again? Or did you all understand? So everybody understood. Okay, so these are basic regression problems where you will be given the values of x and y, and you have to predict the other value of x and y. Now in regressions, the basic understanding is you will have two regression equations. One is y on x, the other one is x on y. Okay, so that is your major regression values. Now let us go on further. uh, 1 second, hold on. Okay, sorry for keeping you waiting. Okay, now next one is regression coefficient. Now what we learned until now is the basic regression values that we'll have to find. But many cases we will also have to find the regression coefficients. So this will be the relative measure for the regression. Now how to find this regression equations, there are certain scenarios that we'll have to find. So again, everywhere you see the common thing in regression is you will have two equations, that is first one y on x and then x on y. If you're talking about coefficients, again it is y on x and x on y. So if anywhere you see, you will have two of the equations and two of the coefficients. Now in this, let us read through what is this regression coefficient. Okay, a regression coefficient represents the increment in the value of dependent variable for a unit change in the value of independent variable. Now if dependent variable changes a little, how much change will it happen on independent variable? Okay, actually what happens is, if suppose, okay, let's say take for example demand and price. Okay, now demand is an independent variable and price is dependent variable. Now if at all demand changes, how much will the price change? Or what is the percentage of effect that is happening on demand and price when there are changes that is happening in the economy? So that can be measured through regression coefficients. So, and it is very easy to understand using regression coefficients rather than solving such long problems under normal regression equations. So these equations we are going to convert them into regression coefficients so that it will give us what is that increment in the value of unit change. Okay, so that rate of change whatever is there, that will help us to understand and make certain arrangements in the business so that we don't incur any losses. These regressions and correlations are very very practically used in many companies, by many departments in the companies also. Okay, so first one, let us understand here regression coefficient of y on x. Okay, and this regression coefficient is denoted by b. b y x. If it is y on x, it will be yx. If it is x on y, it will be b x y. So x will come first. Clear? Now it is given as, what is the formula? So b by x is equal to covariance xy. So we have solved this covariance and variance way before this chapter. The previous chapter we have done all this. So covariance xy, covariance of x comma covariance of y divided by variance. Okay, variance is denoted by y. So this is the formula. Now in simple terms, how you can write? R is equal to, R is the correlation coefficient. If you remember just the previous concept before starting regression, we have solved correlation. So correlation into standard deviation of y series divided by standard deviation of x series. So this is the simple formula for us to calculate the byx or the regression coefficient. Okay, so in this regression coefficient, whatever is given to us, r is the coefficient of correlation, standard deviation of x and standard deviation of y. Okay, so why have we taken only b here? There might be a question which can arise. Okay, why have we taken only b here? Why can't we take a? Since we are saying b is the slope of the equation. Okay, b is the slope of the line, that is the regression coefficient equation. So that is why we consider b. So what does the slope do is, it always represents how much change is happening in the values of the coefficients always. So that will be your byx. Okay, so this is your first regression coefficient, that is byx. Any doubts in this slide? Did you all understand this part? Okay, so let us go on further. We will understand the next uh, regression coefficient, that is x on y. Now the next regression coefficient, that is x on y. Now, one second. So if we happen to see here, now b is xy. Now for this, sorry, for y on x, your b was yx. Now since it is x on y, it is xy. Okay. Again here the formula remains same. Covariance x comma y divided by variance. But here first you will have x and then you will have y. But previously if you see, first you had y and then you had x. It is something like a priority basis. Again, using all this, we will be calculating the regression coefficients. Now, to find these regression coefficients, we need to have two equations. Now, without equations, we cannot, or without the values of x and y, we will not be able to calculate standard deviation or correlation coefficient. So, for that, again, we will have to, solve these equations using two methods. Okay, so regression equation can easily arrived by using the regression coefficients. For this purpose, we have to calculate, uh, you know, uh, the regression and the correlation by two methods. Now, what are the two methods? Actual mean method and assumed mean method. In actual mean method, we will be using x bar directly. In assumed mean method, we are going to assume one of the number to be mean. Okay, so first one is actual mean method. Now again, let us see how it is done. Now, firstly, y on x they have taken. Okay, so the first one is y on x. So y is equal to a plus bx. And if you remember, these equations are same of y on x which we calculated before. Okay, so these are the same expression which we calculated before. That is, the same equations are considered here. Okay, now let us read further. When deviations are taken from x bar and y bar, okay, we have x and y, right? So x bar and y bar, the regression line of y on x is equal to yc is equal to a plus bx can be written as, okay, how can they write? Y minus y bar is equal to b into x minus x bar. So when they take deviations from the actual mean, they can rewrite the expression, okay, they can rewrite this expression, okay, as y minus y bar is equal to b into x minus x bar. They have just taken out this a part here. Okay, now if at all I denote this y minus y bar by a small y, okay, if I denote y minus y bar by a small y, and if I denote x minus x bar by a small x, then I will come to the simple equation which is y is equal to bx. Next, now you understood till here? Any doubts till here? Deviations from actual mean. Okay. Now, once we have done, so we have got one expression, that is y is equal to bx. So we have y is equal to bx. Okay. Now, going on further, we took this expression, we took this equation and we got this small equation. Now, let us take these two simultaneous equations and derive some value. Now, taking these two simultaneous equation, expressing normal equations in terms of y and x. Now, what is y? Y is equal to y minus y bar. Small x is equal to x minus x bar. Correct? Now, we know that summation x minus x bar, that is summation small x. If you see it's a big capital X, this is small x. Small x is equal to 0. Now, why it is equal to 0? Because you will have certain plus value, you will have certain minus values which will nullify whole of the values and make it 0. Okay, or you can also take this as assume. Okay, assume summation x. Now summation small x is nothing but deviation. So deviation is equal to 0. Here deviation of y is also equal to 0. Now we will be putting or we will be taking this first equation and we will be substituting sigma x and sigma y to be 0. Okay, now let us take here, let's go on here. First, write down the same equation, sigma y is equal to Na plus b sigma x. Let us take the second equation also, sigma xy is equal to a sigma x plus b sigma x square. Okay, so here what will happen is, for first equation, if you put 0, now sigma y is also 0, na will remain. Okay, there is no x and y there. Again, b into sigma x is also 0, so b into 0 is 0 again. So what you'll be left out with here, 0 is equal to na plus 0. That will be the equation left out. So what we are doing, we are just ignoring this 0. There is no point in writing that, it is fine. So we will just leave out this 0 here, and we will just keep na is equal to 0. So that is what is the expression here. Okay, now in the second expression, let us substitute 0. In the second expression, let us substitute 0. Okay, so here if you take xy will remain, because it is not x or y separately. So xy will remain. That you cannot assume as 0. So xy will remain as it is. Then a into sigma x. Sigma x we have taken 0. So that 0 will be considered here. Then b into sigma x square. So x square cannot be 0. See, simple assumption is sigma small x will be 0 and y will be 0. So x square, y square, other multiplication, division, all that we cannot assume. Only these two values are assumed. So only that we were substituting to be 0. Okay. So sigma x square will remain as it is. Now here xy is remaining. Only in the part of sigma x we have put 0. So a is equal to sigma x. Then plus b into sigma x square. Okay, so that is where we get this value. So this is the next equation that we are able to get from the by substituting x and y to be 0. Okay, did you all understand the equation until here? Any doubts until here? Okay, now from here what can we infer? Now you can take n onto the other side. So this na is equal to 0. If I take n onto the other side, it will become 0 by n. Okay, so a is equal to 0 by n, which is nothing but 0 again. So I can infer that a is equal to 0 in total. So this is my first inference. Now from this equation 2, what can be my inference? Now we have xy and x square, both are available. Okay, so let us simplify this part. So I'll just write here. So you have sigma xy is equal to, let us ignore this 0. Okay, if it's there or not, it still is fine. Okay, so b into summation x square. So sigma xy is equal to b into summation x square. So this is what we have. Now, if we keep b as it is and send x square to the other side, what will be the expression now? Summation xy is divided by summation x square. Summation x square is equal to b. Correct? So, to calculate the value of b, I got another or the basic formula, that is summation xy divided by summation x square. So this is how we find the regression coefficient for y on x. Okay, where a will be 0, and b, that is your slope of the regression coefficient, will be summation xy divided by summation x square. Okay, so this is first equation which we derived. This is the actual formula for regression coefficient. So when they give in the problem, we just have to calculate xy and x square, and then we will be able to solve the regression coefficient for y on x. I hope everybody understood this. Any doubts until here? This procedure is important to be known, because if at all in problems they give you equations and then ask you to derive it, then it will be a problem if you don't understand the basics of the equation derivation. So that is why we will learn this. If they give equations, you should be able to solve or come to this position, or if they give at this expression, you should be able to take it back to the equations. Okay, so everybody understood until here? Any doubts? We will solve problems under this also. Understood? Okay, great. Now, what we will be doing this is this expression, the regression coefficient, whatever we saw here, we are gonna substitute this in this first equation, that is y is equal to bx. Now, how do we do that? Now, y minus y bar, this is your deviation, is equal to byx into x minus x bar. So y is equal to bx. So in that equation, small y is nothing but y minus y bar. Okay, is equal to, in the place of b, I am writing byx, and in the place of small x, I write x minus x bar. Okay, then going on further, they've just given out the same equation notations, that is x bar is arithmetic mean of x series, y bar is arithmetic mean of y series, byx is regression coefficient of y on x, and byx formula is summation xy by summation x square, that is nothing but correlation coefficient into standard deviation of y by standard deviation of x. Now here they have not given how they arrived at this expression. Let us see that later, because it will be complicated for you to understand every derivation. Okay, so this basics is enough for us. Understood until here? Now, going on further, similarly, we have also derived the equation for the other series, or for x on y regression line. So first what we did until now was y on x. Now similarly we have done for x on y. Now for x on y, you will have x minus x bar is equal to b into y minus y bar. Okay, now here the simple equation will become x is equal to by. Again taking the equations here and substituting summation x and summation y as 0, the first equation you will be getting na is equal to 0, because it is just interchange of x and y places. So again you will get a as 0 only. Now going to the second equation, sigma xy is equal to, so xy will remain as it is. Then in the place of in the place of xy, we have 0. So you will have a into 0, which is 0 again, plus b into sigma y or summation y square. So what will happen here is summation xy is equal to, you have uh, b summation y square. Now I am taking y square to the other side. So you'll have an expression of summation xy divided by summation y square, which is equal to b. So we end up with this complete equation here. Okay, so that is the value of b. Okay, so that is the value of b given here. Then going on further, this is the regression coefficient for the line x on y. Now the derivation, everything is same like how we did previously. So that is why there is no too much explanation given here. So simply we are substituting the values for sigma x and sigma y is equal to 0, and we end up with this formula for the regression coefficient. Now once we know the formula for regression coefficient, let us put them into this simple formula. Okay, so that will be x minus x bar is equal to bxy. Now here it is the regression equation is x on y. Okay, so they've just confused themselves here. This is x on y. Okay, so x on y can be written as x minus x bar is equal to bxy into y minus y bar. So what does all this mean? X bar is the arithmetic mean of x series, y bar is the arithmetic mean of y series, and then you have bxy, which is regression coefficient. Now what is the formula for regression coefficient? Summation xy divided by summation y square, which is equal to correlation coefficient into standard deviation of x by standard deviation of y. So this is how we end up with two regression coefficients, that is x on y that is given here and y on x that we saw previously. Okay, so did you all understand this derivation and the equations? Before we start the problem, this basics is much needed. Any doubts here? Everybody understood? Okay. So we will stop the class here and we'll continue it later.